Served as a visiting lecturer at Jalpaiguri Government Engineering College, Jalpaiguri and Shiliguri Polytechnic, Shiliguri. Dr. Datta has awarded with BE in CSC from University of North Bengal, MTech from Jadavpur University and PhD from University of Kolkata. He has published a number of research papers in international conferences and journals, indexed with SCIE, Scopus, DBLP, etc. His current research includes data mining, pattern recognition, and cyber security. Sir, Subrata Datta sir, I request you to start our very first session.
Thank you for your nice introduction. Am I audible? Am I audible? Can you hear me?
Yes, sir. Yes, sir. You are clearly audible. No issue.
Okay. Thank you, Professor Nayak, and thank you, ma'am, for your nice introduction. So, may I start my today's session now? Oh, okay. Good afternoon, everybody. So, is the slide is visible to you? Is it?
Yes, sir. Yes, sir.
Okay.
It's clearly visible.
Okay. Thank you very much. Again, good afternoon, everybody. And I'm very much thankful to the Department of CSC, HALDIA Institute of Technology, for organizing such a kind of FDP program, and they've invited me for a AI-based lectures. So today's world is full with AI and ML and coordinating of these two domains. I'm also interested on these domains and doing some researches on these domains. So some of my research works today I shall deliver a small lectures on rule-based AI. So though rule-based AI is not a new technique in this field, but today, as the agenda of the FDP, I'm trying to commensurate the application part of rule-based AI in this FDP program. So this background of this rule-based AI, it is far back in 1943s, whenever the Post has first uttered this kind of thinkings, where they have proposed something kind of rule that may be used for exploration of expert systems. Later we call it an expert system. However, at the beginning that was not an expert system. So my today's lecture is all these belongings to a rule from expert system, and then a recent application where we can apply this knowledge of AI in solution of the real life problems. Just a minute. Just a technical problem. So just so first of all, I want to tell that what is the background of this rule-based AI. The concept, as I have told, it was in 1943 proposed by Post. Then on that time, the concept was that such a kind of thinking or technology have to be introduced to build up a robust decision. So the background of this scenario of this introduction of AI-based system is to provide a concrete decision-making system. Based on this thinking, some kind of production system has been first developed. On that time, expert system was not there. However, a production system in the manufacturing unit, they have proposed a rule-based systems. Now, a production system actually requires three components. That means actually it is built with three components. The first one is a database, the second one is a set of rules, and the third one is an interpreter for the rules. Now, this a set of rules, this is the second component. From this concept, rule-based AI system has been developed. So rule-based AI system is the backbone of a PS, that means production system. Now this production system later on used for design and development of expert system. So as all of you know that expert systems are used for complex decision-making problems in real life. So if I chronologically summarize the matter, then first the target was to design a production system, and production system has a set of rules. From that set of rules, the concept of rule-based AI has been developed, and then this production system is used in the development of expert system. So this is a little bit background in this particular field. Now the concept why this AI based rule system is actually required. So what it is and why this rule based system is required. So as I have already told that rule based AI actually refers to if-then relationship. That means if I want to develop some kind of transparency in my decision making process, then if-then this kind of relationship is very much important. So this rule-based AI actually refers to the development of if-then relationship. And why it is required? As I have already told, that to development of the expert system, and that expert system will help in the decision making process. So these are some kind of bookish terms that what are the components of rule-based AIs. So there are more than three components. However, these three are the main components. The first one is knowledge base, second one is working memory, and the third one is inferencing. And knowledge base is nothing but it's a repository. We can say it's a repository where the some kind of facts, incidents, and domain-specific knowledges are stored. And in working memory, it is also a kind of, temporary storage place where some operations are happening. It can accept inputs, intermediate results, and domain knowledge also. So domain knowledge means from where you are getting the data. So it is the knowledge, the background knowledge of the data. And in inference engine, this is the most important part, where we try to develop the logical sense of the input data. So this rule-based AI actually works within these three components. Now there are so many application areas of rule-based AI. All of you know that so many applications. I have mentioned a few of them. Market basket analysis, medical diagnosis, fraud detection, quality control, recommendation system, cyber security, weather forecast. So many things are also there beyond this, because it expresses the if-then relationship, and whenever some decision making problem occurs, then you can apply this if-then relationship. Now the most interesting thing is that the current research trends in rule-based AI. So till now, I think we have understood that rule-based AI, basically here we have to develop some kind of rules from the raw data set. So what kind of rules you are delivering, we have to judge the quality of the rules. So this is the fact where the current research is going on. That means if we develop a model to generate some kind of rules, but what is the quality of that rules? So taking this particular question, the current research trends on rule-based AI includes rules with unexpectedness. Unexpectedness means that some common rules, for example, if we make a rule that toothbrush implies toothpaste. So this kind of rules are the common rules. There is no so much information an user or a business person can get from this kind of rules. So we have to develop or extract such a kind of rules where the two parts or if and then relationship are generating does not commonly occurs. So this is actually in simple word called unexpected. So that is we are not expecting that these two parts can make a rule. So finding the unexpectedness is a current research. Rules without some common sense. So these two are quite related to one to another. Rules with rarity, that means what are the products that are that's generally sold out rarely. We have to find some kind of rules in between them. Rules with high correlation, rules with high important facts, automatic rule generation. Some models are researchers are trying to generate some models that can automatically generate some rules without some kind of bounds. Rules with approximation, rules from uncertain data or from dynamic data. So these are some of the areas where the research in present time is going on. So we can minutely follow that in each of these cases, the researchers are actually trying to find out robust rules and the rules that have high information in it. So this is the research trends in rule-based AI. Now today, as the MTP title suggests, so I shall try to explain an application, recent application of rule-based AI in travel landscape recommendation problem. So what is travel landscape recommendation? I shall first discuss that one, then why it is required, then we shall go to the technical background of how we have solved this particular problem. So why travel landscape recommendation is actually required? As we know that we love to visit different places. So the tourists may have prefer visit to different landscape in a spatial or temporal order. So what is a spatial and temporal order? Spatial means, for example, a tourist want to visit the places within India only. So this is the case of spatial, or more specifically, for example, in West Bengal. And what is the temporal basis or temporal order? That a tourist prefer to visit in any place in the month of November, for example. So tourists are bound basically within the two factors. First one is spatial concept and second one is temporal concept. Therefore, travel company should recommend such a kind of tour packages that can cover all the preferred landscapes. For example, I want to visit Kolkata, then Dakshineshwar, then some around places. So travel company should generate or should build up such a kind of package that cover all these places. Otherwise, it should not be lucrative to the tourists. Tour package with landscape recommendation provides complete knowledge to the users in the context of visiting place, duration, and costing. Tour package with landscape recommendation helps the tour companies to design lucrative packages that infers high profit margin to the companies also. So this is the reason why travel landscape recommendation is actually required. Now, what is the problem in travel landscape recommendation? The biggest problem is that different customers have different choices. So if there are 1,000 customers that belongs to a particular company, then 1,000 customers may have 1,000 different choices regarding which spot they want to visit, when they want to visit, how much time they want to spend in a particular spot. This is the concern regarding the companies. Another problem is that this is regarding the customer's problem. What is that? Customers are bound with time and cost of travel. So, for example, you have a leave of 7 days. So, you cannot accept such a kind of package that is beyond 7 days, or you are bound with cost of travel. So, for example, if a package cost is 30,000, then you cannot accept a package beyond 30,000. So, customers are bound with two factors, that is time and cost. Companies are bound with one factor, that is customers have different choices in the same geographical area also. And technically, another problem is there, that is customer log data is unstructured in time. So there is no structured data. So here is an example, or you say sample log data. I have not incorporated all the attributes. However, just for a little bit understanding, I have incorporated this table. For example, whenever a customer log in, we are accepting his or her email address, then contact number, then tour start date. Then we have kept 5 places where they want to visit in that package, within that particular package. For example, the first customer want to visit Jaipur, Bikaner, Jaisalmer, Jodhpur and Udaipur. But the second customer, he wants to visit Jaipur, then Jodhpur, then Udaipur. Similar for other remaining customers. So this table shows that different customers have different choices in the same geographical area. If we consider the geographical area Rajasthan, then different customers have different choices regarding the spots. So it is a problem for the tour companies to design a package that may fulfill the customer's choice. So this is the real life problem. And another problem is that different customers want to spend different amount of time in different places. For example, somebody may want to stay Jaipur for 2 nights, whereas somebody may opt for 1 night, though their destination may be the same. That means if 2 customers want to visit the same destination, same spots, but they may want to spend different amount of time in each of the spots. So that is another problem in this log data. So here is a picture that Rajasthan landscape recommendation options. From here, we can easily understand that there may be different views from different companies that how they will design a package that can cover the renowned tour places. So any company can design any route. That means any company can select any route. So this is a completely ridiculous matter that a customer cannot get proper, package that can fulfill his or her expectation. And companies are also facing problem that different customers have different choices regarding the visit of same places. So in this figure, you can see that there are four options available. Rather say there are multiple options are available. I have only put it four ones here. So from these four ones, we can easily understand that designing of travel landscape package is a typical problem. That's why if you search in different tour companies, for example, Make My Trip, Easy Trip, so many companies are there. You will find that for the Rajasthan tours, for example, Rajasthan tours, they have different packages. So that is the reason why they develop different kinds of packages. Now, if we simplify the log transactional database, that means we are transforming from log data, here it is log data example, from here we can generate the log transactional database. Obviously, the attributes that are not necessary for rule-based AI, we can omit those one. So this is an modified database. The attributes that are necessary for developing a rule-based system, we are only taking those attributes. For example, the first column tells the first attribute is the customer ID, and we are taking the second category of attributes, that is different scores. So from this table, it will be very much easier for us to understand that different customers have different choices in the same geographical region. Here the same geographical region means Rajasthan. So within the jurisdiction of Rajasthan, we can find that customer 1 and customer 2, they opted for tourism purposes different places actually. So by this way, this particular database tells you from there we can get a knowledge that different customers have different choices actually. So the problem is that here in this table only 10 customers I have incorporated, but in reality there are thousands and lakhs of customers are there. If we examine the tour data from the government side, then we can imagine that how many numbers of tourists per year they visited Rajasthan or any other places actually. So here we have taken only a sample of 10 customers, and from here we can understand that different customers have different choices. So the problem for the company is that how they will design such a kind of package that may be lucrative for the customers. So this is the problem here. For example, if a customer design a package with suppose Jaipur, Bundi, Kota, Chitragarh, Udaipur, then the customer, for example, C4, he wants to only visit the Ajmer, will not accept that particular package. So that is the problem. So the task is to recommend best suitable travel landscape. So this is our task actually. So what is the solution? Under the rule-based AI, we have tried to solve the problem with high occupancy item set mining. So this is a new area of actually mining part, rule-based mining. So this is actually called high occupancy item set mining. So now we shall discuss the technological background of the solution. So what is actually the occupancy? Technically, occupancy relates with the idea of occupying spaces. So what is the meaning of occupancy? If we think in very simple sense, that occupancy relates with occupied portion. But in this case, here it is not the meaning of occupying any places. It is the meaning that how much an item occupies a portion of a transaction. What kind of transaction? That means if we go back to this particular table, then for each of these particular places, each one will be an attribute. And each tuple that will be considered as a transaction. So for example, if we take the Jaipur, this particular attribute, then Jaipur, this one, how much portion it occupied in the transaction 1, how much portion it is occupied in transaction 2, similarly for transaction 3, transaction 4, look like this. So here, this particular notion of occupancy means that the portion that is occupied by an item set in its supporting transactions. So what is supporting transactions? Supporting transaction means where the item or the product that has been transacted. That means that has occurs in very simple word. So occupancy measured the portion occupied by the item set in each of the supporting transactions. Now, in few years back, the concept of occupancy relates with only the item set occupancy. That means the older concept in occupancy measurement that only relates with the item set occupancy. But later on, some transaction occupancy concepts are also introduced in the literature. So, in summary, that occupancy are of two types: item set occupancy as well as transaction occupancy. So transaction occupancy, actually it is measured, it is abbreviated as TO, and it is defined that TO of a transaction, TJ. So small tj, it is the notation of a particular transaction for j equal to 1, 2, 3, 4. If j equal to 1, that is first transaction, j equal to 2, then second transaction, look like this. So TO means transaction occupancy of that particular transaction. It is simple probability of the belonging set of items of that particular transaction. So probability, P means probability of BSI. BSI means belonging set of transactions. So what is belonging set of transaction? I shall later explain with the help of an example what is actually belonging set of transactions. For example, we are taking this example, transactional database. So there are 15 transactions. They are identified by T1, T2, look like this, up to T15. And some items are written against each of the transactions. For example, T1, here the items, related items are B, C, D. So we can consider B is Jaipur, C is Udaipur, and D is suppose Kota, for example. And T2, A, G. So A is another place, G is another place. Look like this. So here some notations are used instead of using some kind of actual proper place names. So from T1 to T15, there are 15 transactions. So from these transactions, how this transaction occupancy first measured, that we shall discuss now. So first we are taking the transaction T2. So T2 means here the item or place A and G has been transacted. So how many items are there? So BSI T2 equal to, it is a set actually. So A, G. So the BSI of AG recurred in T2 with normal recurrence, and in T6, T10, T11, T12 and T15 with shared recurrence. So this is the repetition of the same set actually. So if we consider here T2, that is AG. Now, if we minutely follow that in how many other transactions this set means AG has occurred. So if we find that in T6, we will find also AG. In T10, we will also find AG. In T12, we will also find AG. In 13, AG. And in 15, AG. That means, if you think that A is Jaipur and G is Udaipur, now T2 means particular Mr. X, suppose. Mr. X want to visit Jaipur and Udaipur. So, in T6, Mr. Y, he wants to visit Jaipur and Udaipur along with other places. That means some choice of T2 is matches with T6 at an extent. I'm not saying that totally matches, but at an extent. Similar cases for the T10, T12, T13 and T15. So from here, we can get a concept that what is the portion of AG, that means what is the occupancy of AG in different transactions, where we find AG. So that is we actually calculated here. That means in T2, AG is completely different, it's a set, and in T6, T10, 11, 12 and 15, they have occurred in shared basis. That means along with other items also or other places also. So total recurrence of BSI AG is 6. How 6? Because there are in 6 transactions, 6 number of transactions, the BSI of T2 has occurred. That means we found BSI of AG in 6 number of transactions. So the transaction occupancy of T2, that means probability of BSI T2, that means probability of AG, that is equal to 6 by 15. As 15 is the total number of transactions in the database. So 6 by 15, we get 0.4. So this is the simple calculation. It's a probability based calculation of calculating the BSI. So here this table actually shows that by the same way, for each and every transaction, we have calculated the transaction occupancies. So the first column, TID 1 to 8, corresponding TO is present. Then third column again TID, remaining ones, and fourth column the corresponding TOs. So by this way actually we calculate the TO actually. The significance of calculating TO is that we want to judge that which transaction has great significance in knowledge discovery. We believe that each and every transaction has no equal importance in knowledge discovery. That's why this TO actually segregates transactions in the context of their significances. So TO makes some differences. If we don't use TO, then we have to by default accept all transactions with equal importance, which is impractical in concept. So that is the thing. Next comes the item set occupancy. So we have calculated the transaction occupancy for each and every transactions in the database. Next comes the item set occupancy. The concept is similar to transaction occupancy, that here an item or item set, how much portion it occupies in the allied or supporting transaction, that is actually known as transaction occupancy. Now calculation of transaction occupancy, it depends on some factors. The first one is set of supporting transactions, second one is support, third one is transaction length. So these three factors, based on these three factors, we calculate the item set occupancy. Transaction length means how many items are present in a transaction. For example, in T2, there are 2 items present, so its transaction length is simple 2. Or we can calculate as a mode of BSIT, same result will come. And support is a parameter or measure that we can calculate from a set of supporting transactions, SST. So what is SST? Actually, the set of supporting transactions of a key item set denoted SSTX. It is actually where the item set actually occurs. If we go back to the database, then if we consider that what are the set of transactions, supporting set of transactions of AG, that is T2, then comes T10, then comes T12, 30, 15. So where this set of items actually occurs. So those are actually known as set of supporting transactions. And its final formula, it is written here, that is IOX equal to summation of TJ. That means until that amount of transaction, we shall make summation where the supporting set of supporting transaction belongs to. If it is 6, then it will be 6 times added. It will be 4, it will be 4 times added. And obviously, TO is multiplied. So earlier concept is only item set occupancy, where this multiplication with TO was absent actually. So absent of TO actually mathematically provides some amalgamous results or duplicate results. So after the implementation of TO, actually results get more vibrant. So here it shows that how IO is actually computed, because until we efficiently calculate the TO and IO, rule generation is not possible under this occupancy concept. So here some kind of BSI for each and every transaction we have written. We have considered here the item A. So item A has occurred in different transactions, that is written in SSTA. So T2, T3, T6 look like this, T50. Now, for each of these transactions, we have to calculate the BSI. That means in the first line, what are the transactions written within the set? For each of those transactions, we have to calculate the BSI. So each and every one is calculated, BSI calculated from the database, this database. Next, transaction length for each of those transactions. That means those are the set of supporting transactions of A. Only for those transactions, we are calculating the transaction length. It is nothing but the mode of BSI. So, for example, in the previous slide, we have BSI T2 AG. So its transaction length is simply 2. For example, next one T3, it will be 4. Look like this, very simple things. So then TO, actually this TO has been taken from the earlier, this particular table, where for each and every transaction TO is present. From there, we have taken TO for the corresponding transactions. Then we have computed this IO, that is item set occupancy for A. The formula is written there. Then we have put it the parameters and value of those parameters. For example, the IO of A, it comes 0.4253. Look like this. So the concept of high occupancy. So we have first calculated the TO, then calculated the IO. Now we are in a position to mine the high occupancy item set for the generation of, for the design of better travel packages. So it is called high occupancy item set. Its formula is X will be an high occupancy item set if its support should be greater than equal to minimum support and IO should be greater than equal to minimum IO. That means here in this model, two user defined parameters are taken. One is minimum support and another one is minimum item set occupancy. These are user defined and it depends on the company or the businessman who are trying to design a package. It is based on their concept. Interestingly, this item set occupancy mining, that means high occupancy item set mining, this pattern does not follow downward closure property. So in item set mining, this particular concept is related with downward closure property. In most of the cases, frequent pattern mining, rare pattern mining, they follows downward closure property. But interestingly, this high occupancy, item set mining, this does not follow downward closure. What does this downward closure property actually tells? It tells that if AB is a frequent pattern, then both of its subsets, that is A and B, will be frequent. But if AB is an infrequent pattern, then all of its supersets will be infrequent. So this is the interesting story. So whenever we know that some item set is infrequent, then there is no need to generate superset in the next iteration. So this is actually the actual benefit of downward closure property. That means if I know that AB is infrequent, then there is no need to generate ABC because it will obviously it will also be an infrequent. But interestingly, this high occupancy item set mining problem does not support this kind of activity. That's why in this case an upper bound have to be issued actually. Now anyone can say that why this downward closure property or upper bound is required, because there is a problem in dealing with item set mining that two main challenges are there. One is pattern missing and another one is pattern exploration. So if we set up such kind of tight bounds, then there is a risk of pattern missing. If we set up very loose bound or no bound, then a huge number of item set may generate that require much more memory space, that require more runtime, that from where making decision is a big challenge. That means it is a simple concept that if we have limited number of if then relationship, then a decision we can easily get out. But if there are more number of if then relationships, then a user faces a big challenge to get a concrete decision. So whenever we want to find the high occupancy item sets for travel landscape recommendation, then we have to keep it in mind that it does not follow downward closure property. Hence, we have to apply such a kind of strict upper bound. Otherwise, billions of patterns may be generated depending on the data set. So from a billion pattern, an user obviously will face difficulties to get a concrete knowledge. To avoid this particular problem and counterattack the problem, we have developed an upper bound that is called IO upper bound actually. And based on this IO upper bound and support this item set as pruning. That pruning means we are neglecting those item sets that does not meet the criteria. So this is a mathematical procedure how we have developed this IO upper bound. it is formulated here. It is a purely classical math based on classical mathematics. Due to short of time, I shall not go through of the development of this upper bound. However, we can use this formula in mining purposes. Another thing we have to apply as IO list data structure, because this is the background of using this IO list data structure is also the same, that mining this high occupancy item set mining does not follow downward closure property. That's why we have to design a separate kind of data structure that is called IO list data structure. Otherwise, this upper bound cannot be developed. So this is the thing, and it is a tuple of 3 parameters actually: TID, TL, and TO. The last line it shows that it is a parameter. It consists of 3 parameters actually. TID means transaction ID, TL means transaction length, and TO means transaction occupancy. So based on these 3, we actually defined this data structure. So this is the actual, form of the data structure. That how each and every one item set, or better say place, where the idea of information of TID, TL, TO for each and every transaction is kept actually. So this data structure actually defined in such a way that for each and every item, for example A, B, C, D, all the 15 transactions, they kept specific TID, for example T2, T3, TL, and TO. This is the algorithm actually. This is a obviously some kind of transactional database as the input, minimum socket and minimum IO, that I have already told that 2 user defined parameters. In this case, we have to consider min sub and min IO, and set of high occupancy items. This is the output of this particular algorithm. So this algorithm actually tells that what we are taking as inputs. First it calculates the TO, then we are calculating the IO, that the method already I had discussed, and then a minor algorithm is called here. So that is called WHEM minor, high occupancy item set minor algorithm. This minor algorithm actually generates the candidate item sets as well as it segregates all the other patterns. So this is the minor algorithm, HY minor algorithm, that is high occupancy item set minor algorithm. If anybody wants, they can develop this algorithm with more accuracy or with more efficiency. Currently, this algorithm actually is based on a priori algorithm. However, anybody can develop or implement this algorithm in a FP tree based algorithm also. So some experiments we have performed on this particular thing. These are some kind of databases easily available in the SPMF repository or FIMI or UCI machine repository anywhere. And different types of these data sets are taken in such a way that they possess different types. They are from different types. So this is the first result, that is number of item sets. This particular algorithm that considers the transaction occupancy generates actually. It shows that it can generate moderate number of item sets. For example, in case of mushroom data set, it is the minimum support 0.5 is taken. So it generates not so high volume of item sets. If the number of item sets are in a limited, then decision making is very easy. The task of decision making is very easy. Otherwise, I cannot say that we cannot take decision from thousands of patterns, but it becomes a clumsy one. So that is the problem. And in case of runtime also, so currently I've already told that this is based on a priori algorithm. However, there is a scope to develop or modify the algorithm using some other kind of data structures. For example, maybe a Petri tree-based algorithms. We can, or list based algorithm, hash-based algorithm. We can implement that one. However, this inclusion of TO, that is transaction occupancy, has significantly improved the model in the context of runtime. So you can see that there is a renowned method, that is HAPE. Actually, this method was proposed by a Chinese scientist, Deng, but he has not incorporated that this concept. That's why it shows that that the proposed algorithm takes less amount of time in case of runtime environment. So there are different data sets have been used, and in most of the cases it shows that the proposed method, that is OIM2, generates the pattern with taking less amount of time in comparison with this state-of-the-art HAPE algorithm. Similar cases there for memory uses cases. And one of the interesting thing is that the proposed method is highly scalable method. So two types of scalability actually tested: runtime scalability and memory scalability. So this OIM2 algorithm performs better, quite better than HAPE algorithm, because in HAPE there is no concept of transaction occupancy. Might be for that reason the HAPE algorithm is not so scalable. However, this OIM2 algorithm, after the incorporation of transaction occupancy, this shows that the algorithm is quite scalable. So in summary, we can say that this concept we can apply in travel landscape recommendation problem, and this proposed algorithm OIM is a way of application of rule-based AI. So this occupancy-based rule-based AI we can apply in a real-life problem, that design of any travel landscape for any company. So this is the actually significance or application of this particular study. If somebody interested, they can go through these particular publications. Okay, thank you. If someone has any question, or they can ask me regarding this.
Thank you, Dr. Subrata Datta, sir, for this incredible session. I would now like to ask the audience if they have any queries. They can directly ask sir, or they can drop their queries in the chat box. Anyone, if they have any query, you can directly ask sir. He is available with us right now, or you can drop your queries in the chat box as well. Sir, so I think there are no more queries from the audience. So should we wait for some more time for the queries?
Or if anybody wants to communicate with me, you can, from your program, you can share the email IDs also. Okay. So
okay, sir. So please, can you drop your mail ID in the chat box?
Okay, sure.
Thank you, sir.